Not sure whether reverse osmosis or distilled water is better? Both of these water purification methods remove a broad range of contaminants, but they work in completely different ways. I'm going to explain the exact differences and break down the pros and cons of each to help you decide whether reverse osmosis versus distilled water makes the most sense for your home. The demand for domestic water treatment solutions is intensifying, with the global water filter market estimated to reach $24 billion by 2032, up from $14 billion in 2023, primarily driven by the rising consumer awareness of water safety and quality. Simply put, the more we're learning about the contaminants in tap water, from lead and PFAS to disinfection byproducts and microplastics, no wonder more people are taking water treatment into their own hands. And with reverse osmosis and distillation being two of the most comprehensive methods of water purification, it's no surprise that these are both such popular solutions for those concerned about their water safety. So, starting with reverse osmosis, the process involves filtering water through several different stages of filtration, including a sediment pre-filter to trap suspended particles like dirt and rust, a carbon pre-filter that reduces chlorine and other organic chemicals, the RO membrane itself, which filters out microscopic impurities, a carbon post-filter to improve the taste, odor, and target any VOCs that might have slipped through, and a final optional remineralization stage to add back in healthy minerals. Water is forced through the system under pressure, and different impurities are removed in each stage. The true magic happens in the RO membrane, which has tiny pores as small as 0.0001 microns. While water molecules are small enough to squeeze through, most impurities, from bacteria and viruses to minerals and metals, are rejected and flushed away with a small amount of wastewater. There are a few exceptions though, and some pesticides, solvents, and dissolved gases can actually slip through. That's why most systems include carbon filters, which address these types of contaminants. Reverse osmosis has become a widely endorsed method of water purification, with organizations like the Water Quality Association noting that RO systems can remove various inorganic compounds, including ions and metals, as well as organic chemicals and pesticides. The effectiveness of reverse osmosis has been proven by numerous scientific studies, including most recently a 2024 study which found that over 90% of RO systems effectively remove both long and short chain PFAS. That same study also reported that residential RO filters remove up to 99% of lead. Another 2024 review identified RO as one of the most promising methods for removing contaminants of emerging concern, including pharmaceuticals and endocrine disrupting compounds. And a 2020 study that found that combining RO with activated carbon significantly reduces 32 common organic contaminants. RO water is incredibly versatile. You can use it for drinking, cooking, making coffee, or even filling aquariums, as long as you remineralize it first. But the reverse osmosis process does have a few specific limitations. Most importantly, it creates wastewater, and it also greatly reduces mineral concentrations in the purified water. Okay, now let's talk about distilled water. Unlike reverse osmosis, which filters out contaminants, distillation purifies water through phase changes: boiling, evaporation, condensation, and collection. Here's how it works. First, water is heated until it boils. As the water evaporates and the steam rises, most contaminants are left behind. Then the steam cools and condenses and turns back to liquid. Finally, the purified water drips into a separate collection container. Since most contaminants have a higher boiling point than water, they remain behind in the boiling chamber, while only pure water vapor makes it to the collection stage. This means that distilled water is virtually free of impurities. However, some volatile organic compounds, or VOCs, can actually slip through if their boiling points are similar to or lower than that of water. To address this, many distillers include carbon filters that capture these contaminants before the water reaches the collection vessel. The process of distillation has been used to purify water for millennia, and these days, the WQA recommends distillation for removing a wide range of contaminants, including lead, contaminants that cause taste and odor issues, and pathogenic or disease-causing microorganisms like bacteria, viruses, and cysts. Despite its effectiveness, and just like reverse osmosis, distillation does have a few key drawbacks. It removes all the minerals from the water, which can cause it to taste bland or what some folks describe as flat. And unlike RO filters, distillers aren't equipped with remineralization filters, so you'll need to add minerals back manually. Distillation is also painfully slow and energy intensive, taking an average of 4 to 6 hours to distill just 1 gallon of water using an at-home countertop distiller. So now that you know how both processes work, you've probably already started to pick out some of the key differences. The biggest difference is how each process purifies water, as I explained a minute ago. Reverse osmosis uses membrane separation, where pressure forces water through multiple filter stages, including a semi-permeable membrane. Distillation, on the other hand, relies on evaporation and condensation to separate pure water from contaminants. While both methods remove the vast majority of impurities, there are certain contaminants that each process might not be best suited for. For example, although reverse osmosis is capable of filtering out microorganisms larger than the membrane's pores, RO systems really shouldn't be used as primary treatment for microorganisms like bacteria due to membrane fouling and contamination risk of the internal components of the system. On the other hand, distillation can be used to make microbiologically unsafe water safe to drink. The boiling during distillation kills microorganisms, making it a form of disinfection. However, water distillers can't always remove some VOCs that are capable of evaporating and condensing with water molecules. Another major difference is efficiency. Reverse osmosis works quickly, providing purified water on demand, either through real-time filtration or from filtered water stored in a tank, while distillation, on the other hand, takes hours. However, distillation doesn't waste water, while reverse osmosis systems do. Even the most efficient models reject at least a small amount of water during operation as an unavoidable aspect of how the process works. Like I mentioned, both distillation and reverse osmosis have an impact on the mineral content of the purified water. Distilled water is completely stripped of minerals since they don't evaporate with water, and as a result, it typically has a pH lower than 7. RO, on the other hand, may retain traces of minerals because the process rejects a percentage of the dissolved salts and minerals in the feed water. Systems with remineralization filters restore minerals like calcium and magnesium, which raise the pH and improve taste. While both reverse osmosis and distilled water can be used for drinking, cooking, and household appliances, some applications favor one over the other. Distilled water is often required for medical equipment, lab experiments, and lead-acid batteries because it's completely free of dissolved solids. RO water is more commonly used for general household needs, as well as in aquariums and hydroponics, as long as it's remineralized. And if you've ever tried both, you've probably noticed a difference in taste. Distilled water is often described as tasting poorly, because it lacks all those dissolved minerals, making it taste bland or flat. Compare that to reverse osmosis water, which still contains a small percentage of natural minerals which enhance flavor, and even more if a remineralization filter is used. Now that we've covered the key differences, do you know which one you should choose? The truth is, there's no single best option between reverse osmosis and distilled water because it all comes down to your unique needs and preferences. Reverse osmosis water is best if you want a fast and efficient purification method that works on demand, you prefer water with some minerals for better taste and pH balance, you need purified water for drinking, cooking, or aquariums, you want a continuous water supply without waiting hours for purification, and you're okay with a system that wastes a small amount of water during filtration. Distilled water is best if you need the purest water possible, especially for medical devices like CPAP machines and humidifiers. You want a one-time purchase system with lower ongoing costs. Distillers don't require as many filter changes like RO systems. You're using water for applications where mineral buildup could cause damage, like ironing or other household appliances. And you don't mind waiting for the long purification process. For everyday drinking water, remineralized RO RO water is the better option. For most folks, it's simply an easier, quicker, and more feasible process to deal with. Remember, distillation takes 4 to 6 hours just to distill 1 gallon of water, while reverse osmosis, on the other hand, provides instant access to filtered water. However, if you prefer absolutely pure water and don't mind the bland taste, distilled water is still safe to drink. Just make sure that you're getting essential minerals from your diet. Now, I've tested and reviewed tons of reverse osmosis systems, so stick around and watch the next video to find out which are actually best based on our objective, data-driven scoring system. Click or tap to keep watching.